Hey class, moving on to 7.6. This one's all about solving equations, which I think are kind of fun to do. There's going to be algebra involved, of course. All your techniques for solving equations come into play. Using identities will be there. And then, of course, we're relying on that unit circle that maybe you have memorized, but if not, you have it right here as a reference. Okay, so let's jump right into some problems. How about number one? We've got to, and it's really important on these to read the directions because they're all a little different. There's lots of variation, I guess. So key here is we got to find exact value and within that interval. Okay, so this is specifying that we need radians because it does specify radians in that interval, and just one full rotation around the unit circle. An exact value, which means no decimals. We want the pi's and fractions and stuff like that. Okay, so the first thing you're going to want to do on these is, if it's not already done, solve for the variable, which is the trig function, right? So you want to solve for sine x, which is pretty easy to do. Just going to divide both sides by 2. Right? Just use your regular equation solving techniques, right? And then we've got to figure out the sine of what angle is root 3 over 2 between 0 and 2 pi. That's where I would like to just use my unit circle. I'm looking for y values, right, that are root 3 over 2, that second coordinate, root 3 over 2. I know sine is positive in quadrants 1 and 2, so I find 1 right there and 1 right there. So those top 2 angles, and those in radians are pi over 3 and 2 pi over 3. Final answer. And so I can just write it with a comma between, and I'm done. Okay. How about this one? Cotangent number 2. So I've got to first solve for that variable cotangent x. So my first step would be to subtract 5 on both sides, right? So I'm going to get 3 cotangent x equals -3, and then divide both sides by 3. So -3 divided by 3 would be a -1. And now it's all about unit circle. Any place where cotangent is equal to -1. You remember cotangent is the ratio of the y over x in the unit circle. I mean the x over y, sorry. So where are the x and y the same, but just differ by a negative? Okay, so let's get rid of those. Let's see, same but differ by a negative. There's 1, and there's 1. Right? If you took the ratio of those, it would be equal to -1. And so there's your 2 answers, 3 pi over 4 and 7 pi over 4. Okay. In my face-to-face classes, I would really encourage, or maybe even require, students to do these without the unit circle, having that memorized. So work on that. I really encourage you to do that. Try these without having to refer back to that unit circle. But if you need to, you have it. Okay. How about the next one, number 3? Let's solve that for cosine x. So I have to subtract the 50 over. That's going to give me 25 cosine x equals -25. And then divide by 25. This seems like the last one. I get cosine x equal -1. Think about, where does the cosine equal -1? Your x coordinate, your first coordinate, -1. There's only one location on this rotation, and it's right there. So this one, the answer would be pi. Okay. Number 4, we got a squared. So I'm gonna again try to solve. Your first step is algebra, really. Move that 9 over. Get sine squared equals 9. And then to get the sine by itself, square root both sides. So you're going to get sine x equals plus or minus the square root of 9, which is 3. So plus or minus 3. Ooh, but is there any place on the unit circle where the sine is 3? The answer to that is no, because this number always has to be less than 1 or greater than -1 for there to be an angle. So this one has no solution. Tricky, tricky. Okay, so you will get some no solutions occasionally. So watch out for those. Okay, we'll just get a little more advanced now. Remember from algebra, if you have two binomials multiplied together equals 0, you set each one equal to 0 and then solve, right? So that's what I'm going to do with this one. I'm going to have tangent x minus 1 equal to 0, or square root of 3 tangent x plus 1 equal to 0. Okay, so I just have more work to do, but it's more of the same. For this one, isolate that trig function, tangent x equal to 1. And now think between 0 and 2 pi, where does tangent equal to 1? So back to using my unit circle. Remember, if tangent is equal to 1, the x and the y are the same. So that's going to occur there, there, and there, right, where the x and y are equal. So I got pi over 4 and 5 pi over 4. Okay, so there's that branch of answers. Okay, this one, I'm going to bring the 1 over. So I got square root of 3 tangent x equals -1. Tangent x equals -1 over root 3. Right. So remember, it's sine over cosine, or y over x. So I need a ratio where the top is 1, or even, if it helps, think of it this way: 1/2 over root 3 over 2. It's the same thing, negative. So I want my y to be 1/2 and my x to be root 3 over 2, and one of them to be negative. Right? So y 1/2 and x root 3 over 2. I see 1 right there. And right there. Okay, so one of them is negative in each one, or tangent is negative in quadrants 2 and 4. It's another way to think of it, but the y is the 1 and the x is root 3. So those are my two answers: 5 pi over 6 and 11 pi over 6. All right. Oh. Okay, so I get 4 answers on this one. All right, those two and those two all together. Okay. All right. We kind of got in the way of this number 6, but let's do this. Let's just shrink that and move it over a little bit. Okay, give us some room. Okay. Here I have now a trinomial. Remember trinomials, how to solve them? So the first step is to factor, I also notice here that the coefficients 6, 9, and 3 are all divisible by 3. Probably divide that out real quick. Just divide out a 3. That's legal. So I get 2 cosine squared minus 3 cosine x plus 1. All right. And then we've got to do a factoring. Right. So where your variable is cosine x. So I know let's zoom in a little bit here. The first two terms, this has got to be 2 cosine x, and that's got to be cosine x, right? To multiply to get that 2 cosine squared x. And then the last terms both have to be 1, because 1 times 1 gives you that 1. So here we just got to get the signs right. And to get a positive 1, but a negative there, these both have to be negative. Right? -1 times -1, positive 1. And then the outside is -2 cosine x, and the inside is -1 cosine x, which equals a -3 cosine x. So we got that factored right. So that's factoring from algebra, just you got a trig function as your variable. Right. Now you can break it up into 2. So this is going to be 2 cosine x minus 1 equal to 0. And this is going to be cosine x minus 1 equal to 0. Okay. If I solve this, I add 1 divided by 2, that's a half. this one, 1. So on my unit circle, I'm just thinking, okay, is there any place where the cosine is a half or the cosine is equal to 1? And you could think about it or look at it. Cosine 1/2 happens there and there, right? And cosine equal to 1 happens there, right? Looking at that x coordinate for the cosine. So I got 3 answers. I got 5 pi over 3, pi over 3, and 0. Pi over 3, if I just put them in order, 5 pi over 3, oops, 0. Right. Okay. So keep on going. A couple more. Let's finish off this page. This one, notice that our directions are changing. Still got exact value, but now we've got degree mode. So you want to give your answers in degrees for this one. Okay. We got this. So this one, we got a sine and a cosecant. So I would use some identities on this one. Let's get everything in terms of sine first. This cosecant is 1 over sine. And then we're going to multiply through by sine to get rid of that fraction, right? Okay, so this is going to be 2 sine squared theta plus 3 sine theta equals -1. The sine theta will cancel on that side. All right, now bring the 1 over and we get a trinomial. So set this equal to 0. And that one looks similar to the one we just factored, except for everything is positive. So this is going to factor into 2 sine theta plus 1 and sine theta plus 1. Break it up. So each one set equal to 0. Okay, and then solve for sine theta. Do that on each one. Okay, and how's that look? I know. So if I ever go too fast, hit pause, take a break, rewind it, and keep at it. Okay, let's see. Any place on the unit circle where the sine is -1/2 or the sine is -1, those are answers. Right, so sine -1/2 or sine 1. Remember, sine is the y coordinate. Right, so sine -1/2, there's 1. Sine -1/2, and then sine -1. There you go. Right, there's your 3 answers: 7 pi over 6, 3 pi over 2, and 11 pi over 6. Oops, but in degrees on this one: 210, 270, 330. 210, 270, 330 theta. Okay. All right, let's try one more for this little session. Number 8. What's going on here? I mean, one instinct you might have is to divide out that sine squared on both sides, but you can't do that because you're going to eliminate some solutions that work. So instead, get everything to one side. All right, so I'm going to set this equal to 0. So this is going to be sine squared minus √2 cosine theta sine squared theta. There, so get everything to one side. Now you can factor out that common factor of sine squared. And if you take out the sine squared, you have a 1 minus √2 cosine theta. Okay. Now you can set each part equal to 0. So you have sine squared equal to 0, or you have 1 minus √2 cosine theta equal to 0. So set each piece equal to 0, and then solve for the variable cosine theta. So this would be sine theta is the square root of 0, which is just 0. And this one, I'd have negative root 2 cosine theta equals -1 if I bring the 1 over, and then divide by negative root 2, it's going to cancel that negative. You're going to get 1 over root 2, which is the same as root 2 over 2. Okay, so where does sine theta equal to 0? Sine theta equals 0. Two places that I see, here and there. Right? So we've got 0 degrees and 180 degrees. Okay. So that's the sine. Put those down, 0 and 180. Okay, and then how about cosine is 1 over root 2, or root 2 over 2, positive. So cosine positive root 2 over 2, I'm looking at x coordinates there, there. You know, cosine's positive in 1 and 4, so I kind of look there. So that looks like 45 and 315. So that's the two answers for that branch. 45 and 315. And then there's my 4 answers. Okay, so we're on our way. There's the first couple pages of this handout. We'll continue in the next video. Hope it's making sense. Send questions my way if you have any. All is well. Bye.